Hey everyone, so in this Vellum chapter we talked a lot about cloth, but we actually haven't talked about clothing or clothes. And this is naturally something that came up as a question by students. How do you do that? Now I put it in the bonus section because it's actually a pretty big topic. It's a bit too complex and too long-winded to cover it in detail in a fundamentals course. Now nonetheless, it's an important topic, and let's first talk a bit about theory. Now there are basically two approaches how to attack clothing. The first one is you model and design and sculpt your clothes on the people already, and then you simulate it. Now this might seem very natural, but it comes with a lot of problems. The main problem is that the detail, especially the folds that you sculpt into your geometry, is now basically treated as the neutral state of the cloth, which is not true because the folds that you see in clothing is usually a result of the way it is built and also, of course, gravity. And I'm not saying it's always the wrong approach, but when you do that, don't be surprised that the behavior of your cloth can end up a bit unnatural. And this is also true when it comes to seams. So when you look at normal clothing, your t-shirt or your sweater or whatever, you will see that there are particular seams around the arms and along the sides of your body. And that is important to the way how your clothing is stretching and behaving when you simulate it. So all these things you have to take into account when you create your cloth. And this is why it's often not such a good idea to create or model or sculpt the geometry on the body of your character already, but it's often better to basically build the cloth from scratch. There are a couple of other programs that specialize in this kind of thing. For example, Marvelous Designer is purely built around this idea, but you can do the same thing in Houdini, and I want to show you in a simple example how you do that. I will not go super deep into this, it's just more understanding the concept, but I'm linking a couple of masterclasses from Side Effects if you want to go deeper into this, but at least I can show you the main workflow. So let's look into the example that we have here. We have an animation coming from Mixamo, as you might be able to see on the character, and then we want to create cloth on top of this. So what I have here for this setup is my character here using KinEffects. It doesn't really matter, but what is important here is that we start with a T-pose. This is where we will create our cloth on, and then after some time it will move into an animation, and we will do this while the cloths are on the geometry. So the core idea is that you actually start with a cutting pattern or a layout that you would use in reality to create a piece of cloth. So for example, you've seen that before, something like this is actually something that you would follow. We will not go so deep that we will actually use a real pattern because that would be too much work, but I want to show you the concept with something we've already seen, and that is that the planar patch has a version called planar patch from curves. And surprise here is where you use curves. For the sake of it, I'm right now just drawing the curve. I would actually use the curve tool, which I will show in a second, but for now, to understand the concept first, let's keep it simple. So here's our T-pose, and again, it's important to usually use a T-pose for this. So let's go with space 3 into a mode where we can see it from the front, and now the draw curve can be used to literally draw here a t-shirt, and I make it simple just for the sake of it, maybe something like this. There you go. This will end up looking horrible. But when you put this into a planar patch from curves, you can see that it creates a geometry for me. So let's change the internal edge length to something that makes a bit more sense, maybe something like this. And the idea now is that you actually take this, and actually in our case, we might have to scale this up a little bit. Actually, from the center, so let's use a transform from centroid to scale this up. And let's move it at the front. And then you take that and also move it to the back. And then you have two pieces that you will then sew together. That's the actual main concept. The main problem here is what parts of this should be sewed together. The node we use to do this is actually called Vellum Drape. And this is the most important node in this whole concept because this makes sure that we can sew those pieces together. Now the Vellum Drape actually, as you can see, expects a constraint because funnily enough, this node is a simulation. So before you can do anything, you have to turn this whole thing into a vellum cloth. So our two pieces here, front and back, we have to turn into cloth with a vellum cloth. And then we take this as an input to our Vellum drape. Now what's important here is also that you add your collision object, which we currently don't have, but we will do this in a second. But first of all, when we press start right now, it will just fall down. And ignore our animation here. Actually, we could for now just do a time shift in there, freeze it in time. There you go. And you can see it just falls down because we didn't tell this the Vellum drape. And as you can see also, you don't need a Vellum solver for this. This is already a simulation by itself. We need to tell it what to sew together. And this is actually built in here under draping, weld additional seams. And here you can define what you want to connect. So it has a main group and a target group. So, you know, as a very stupid way of doing this, you could just select, for example, those points up here and those points up there. Press enter, and you want to sew them together with these points here and these points over here. And press enter. And you can see it tries to find a connection. Now the problem is it doesn't work very well, and we will solve this in a second, but this is basically the idea. Now how do we solve this? Actually, you might guess it. We see a long list of points, so this is actually not a good approach that I would recommend. There are different ways of finding those edges basically that we want to connect. And one is actually that in the planar patch from curves, we can create the seams with the seam groups. Now the interesting thing is it will take the curves that we created as an input and create seam groups from that. So when you look here, we now have 6 different seam groups, which corresponds with exactly 6 curves that we created in the draw curve. To be fair, we don't use that approach that often, but this is the easiest way of showing it. So what we can do now is we can make sure that we have one group for one piece and one group for the other. So for example, when we look at the groups, we could do this, for example, with a color node. Let's turn red one of the groups. So the first one is this one. Okay, the second group is this one. Okay, we don't care about this. Probably we don't want to sew this together, right? This is open, as we know. So the second one is what we need. Actually, let's make sure we call this maybe planar or something, because otherwise the group naming will be too long. So the first one is good and the second one is good, or the third one. And as we can see here, that would be the 2 on the top. Now the problem is that we have 2 versions of this, the front one and the back one. And when we would try to seam them together, they have the group has the same name. So one solution here is to use a group rename for the back one and just say, okay, you know what? We take any group and we add back at the end of the name of the group. And now we have, for the back part, for all the groups that we have had before, we have now 6 groups with a back at the end, which makes it much easier to work with in a second, because in the Vellum drape now, we can choose the 2 top ones, the seam 0 it was and the seam 2, and then the back version of this, of course, is the seam 0 back and the seam 2 back. And now you can see those 2 groups actually match. And before we move on with the other seams, let's press start and see what happens. And you can see it's simulated so that they snap together basically. And here you can see why it is a problem not having a collision object, because this will not, you know, take our body into account. So let's make sure that we actually take our geometry here and put it in as a collision object. And now when we run this, you can see it goes together and it, you know, kind of folds over our geometry. Now the result here is absolutely horrible. That is simply because I wanted to show you the concept, and here's exactly where the problem lies. It can be really tricky to, you know, figure out what the right setup is to have good looking shapes for your cloth, and also finding those groups that we just used. So I prepared this a little bit to save us some time, and what I did here is I actually created our cloth here, also with a planar patch from curves, but this is based on a curve. So here I actually used a curve with a curve tool, which is much nicer, because if you notice later on, and you will notice that you made a mistake, you can just go in and use the curve tool to edit your existing curve, which is much easier this way than doing it with a draw curve. You can do it afterwards with a curve tool with a draw curve as well. We talked about this in the curve video, but you know, starting with this, in my opinion, makes it a bit easier. Then I just mirror the whole thing so that I actually have a symmetric version of my cloth. And then I do some resampling and the planar patch from curves to have a nice cloth. And it took me a while to find a good size. And then the tricky part is to find those curves, because in this case, I don't have multiple curves. I only have one curve. So I had to do a little bit of manual work here. So I found the top parts just with a group. Then I found the edges with a group that I was setting to include edges, and then unshared edges, which will find all the edge points, which is actually not what I want, because I want to have holdouts for the arms and for the bottom. So what I did is I added a group that defines where the cloth should not be sewed together. And then I used, and there are other ways of doing this, but this is something I prefer, I used a simple point wrangle to create my own group with the rule of if the point is part of the edges but is not in the group that should be excluded, then it gets into a new group called sides. And what's left out, you can see here, are those red points here. I know there are other ways of doing this, like the group expression node and all that, so feel free to find your own ways of doing this. My point is, it will probably be a bit of work to create those groups, especially if you want to work procedurally. Try to avoid working with direct point numbers. And then I did the same as we've seen before. I create a front part and a back part, and then I rename all my groups by adding back to the name of it. Then I scale it up a little bit, run it through a Vellum cloth, and then the Vellum drape looks like this. And here you can see the connections are reasonable and will actually stay intact even if the topology will change, which can always happen when I change the base curves. Then the topology will change, and this is why you should definitely work with groups. So anyway, when I run this, you can see now it folds around like this, and this is basically what we want to have in the end. And one thing you notice is that there is no movement on the geometry, and that is because even if you put in here a T-post that is moving, like I actually did here, so the actual input into my Vellum drape is moving, the Vellum drape will only take the first frame. It will not take the animation into account, because that's not what it's for. Which brings us to the next thing. The Vellum drape is not meant to actually simulate the behavior of your cloth. It's purely meant for the sewing. And this is why there is a freeze at frame parameter up here, where you can say, okay, just give me the result of this at frame 1050 in my case, which is, by the way, of course, because I start at 1001. I would not recommend actually doing this because this makes it harder to actually check what the whole system is doing. I personally do this manually with a time shift that I set to the frame that I want. And then you actually take that as a starting point for your simulation. So this now goes into a normal Vellum solver. Out of the Vellum drape still come all the constraints that you can still change in the Vellum cloth. And by the way, that's something I did. I lowered the stretch stiffness, and also, of course, I lowered the bend stiffness to get nicer folds. And this then gets the animated version of my geometry. So if I run this now, you can see that the actual animation is taken into account. There it is. And this is where you will actually then apply your cloth to the moving geometry and actually check how it all behaves. Now, the interesting thing is the behavior of the cloth, of course, is dependent on the Vellum cloth settings. But you could, if you want, of course, change them with the Vellum constraint properties if you want. And here you could override them before you simulate them again, if that's what you want. So this is something that you have to experiment around with. But as you can see, there are two stages: sewing simulation and actually movement simulation. And here on the other side, I have an actually simpler version. For the skirt, I use the planar patch set to ring. This is now actually useful. And what's nice about this is that it has built-in seams that I can just create as groups inside of the planar patch. I still have to, when I separate the front version and the back version, rename the groups with a group rename by the same logic, using a back to the group name. And then the Vellum drape looks like this. There you go. And then you can see it creates those nice folds. And this is a good example where you can see why you would do something like this. The folds that are created here are natural folds. They actually are based on, the overall shape and everything. It's not arbitrary. This is actually what would actually happen. And also, again, this is a constrained geometry. So when you put this then into the simulation, you get all the settings from before, which makes the whole behavior on top more realistic. So in the end, the whole thing looks like this. If we bring everything together and, give it a nice red color. And now you can see there is a little bit of a pre-roll in the beginning. That's totally normal because, you started with the T-pose and it has to settle into the movement. And then you can see how the cloth is, moving hopefully more or less realistic. So that's the core idea, basically working with the Vellum drape as a first simulation to sew together the elements that you created before. You define the shapes and then you define the groups that you want to connect. This is just the simulation to connect the pieces. And then the next step is to turn this into an actual simulation on your animated version. So as I said, if you want to know more about the single steps and the possibilities of this workflow, you can find links on the right side with a couple of master classes from Side Effects. Hope this helps you to understand the approach here. So hope this is helpful. Thanks very much and see you later. Cheers.